Hello. Now, after having solved questions on PV, FE, rate, NPR, and PMT, we'll move on to these kind of questions where the amounts of money that you require every year are different, right? So we have Ramu who wants these amounts of money at the end of each year for next 5 years. At the end of year one, the money that he requires is 50,000. At the end of year two, 75,000. At the end of year three, 90. At the end of year four, 1,05,000, and at the end of year five, 1,15,000. Now the question arises is Ramu wants to know how much should he invest today as lump sum so that he can get these amounts when he requires them. So what do we do? Can we use this series as PMT? No, the PMT is clearly defined as an amount which is equal always. These amounts are not equal and hence this is not a PMT. For a moment, let's think of these as 5 different questions. Let's say I want to invest some money which will grow for 1 year at the rate of 10% and become 50,000. Similarly, it will grow for 2 years and become 75,000. Another sum of money grow by 2 years at the rate of 10% become 75,000 and so on. So instead of treating this as one single question, let's treat it as 5 different questions. Now how would we solve that? In the first question, so let's find present value where rate as given is 10%, and then we have NPR 1, but instead of typing NPR as 1, we will take NPR from B4, right? This will help us drag and we will be saved from the botheration of calculating again and again, right? So Excel does that repetitive work. Future value that we need is 50,000 rupees. Type is meaningless without the PMT being there, so we can close the bracket over here and let's press enter. So 45,454 rupees is required, so which can become 550,000 in next 1 year. Now when we drag it, we will have resultant figures for all the amounts. For example, if you see here, the NPR here is being taken from B5, so I need future value after 2 years with an amount of 75,000. Right now, in order to get our answer, let's sum it up because you require each of these amounts individually to get these future values, right? So when we sum it up is equal to sum, we choose these numbers and enter. So you need 3,18,178 rupees which can be invested to get 50,000 at the end of year 1, 75 at the end of year 2, and so on. Now let's just put a negative sign here before sum so that the answer comes in as a positive value. Okay, now let's go on to a function called as NPV, which will help us do the same thing in relatively lesser time and easily. Now NPV stands for net present value. Now this function is also a function to find PV. It's not something different than PV, but it is used in precisely these places where an amount can't be classified as a single future value or as a PMT. So let me demonstrate the usage is equal to NPV, net present value. Open the bracket. It is asking you for two things. One is rate and another is values. Now values can be n number, value 1, value 2, value 3. As you keep on typing, you can continue to type. So first let's put the rate in 10% and then values. Now you can keep on typing values one by one, but there will be little bit of tedious. So what we can also do is we can click on the first value, which in this case is cell C4. Now as you click, C4 appears here, and then press shift and down arrow key together till the time all your values are selected. So now you see all your values have been selected, and over here you can read C4 colon C8, bracket close and enter. So you got the absolutely same answer for the same question, right? In a much faster way. Okay, now let's change this question a little bit and then see what happens. In this question, we were supposed to calculate assuming that these amounts were required at end of each year, year 1, 2, 3, 4, 5. What if these amounts are required at beginning of each year? NPV function has one crucial shortcoming. Unlike our regular PVFE function, it doesn't have any type column. It just has two data points. One is rate and another is values. So what do you do? Well, NPV function always assumes that the value given to it in the first column, or value 1, is value at the end of year 1. Now, if I were to change this question and ask you what is the amount that you need if these monies were required at beginning of each month, each year, then what would you do? You would say that 50,000 is required at point 0, okay, and that is beginning of year 1. 75,000 is required at beginning of year 2, which is also end of year 1, and then 2, 3 and 4. So each amount is required 1 year early. You will find the answer, corresponding answer, has changed to 3,49,996. Can we do this using NPV as well? Well, there is a little simple thing that we can do. Now in this case 50,000 is required today. Now if you require 50,000 today, the value of that 50,000 is going to be 50,000 only. So let's not bother much about it. Let's go on to the next amount. Incidentally, this amount which is required at beginning of year 2 is also the amount at end of the year, because they are two same things, right? Beginning of year 2 and end of year 1. So what we will do is we will calculate our NPV from this amount. So is equal to NPV, bracket open, let's key in the rate which is 10%, and then values starting from the value at the end of year 1, not beginning of year 1. And if there is nothing coming at end of year 1, we'll have to type start with 0, right? So shift and down arrow key. So that's C5 colon C8, ignoring the value in C4, bracket close and enter. Your answers have still not matched, and the reason for that is that we will need to add the initial 50,000 also, which is required right now, right? So we have ignored that. Now 2,99,996 plus the initial 50,000, so that makes it 3,49,996.58. So now as you can see, it is again matching. So using NPV function, we can find out present value of uneven cash flows. Now in the next session, we will try and find out future value of similar amounts. Thank you.